Hello everyone. The vulnerability we are going to introduce today is cross-site scripting, or XSS for short. There are three types of cross-site scripting: reflected, persistent, and DOM-based. What we are going to introduce today is reflected cross-site scripting. If you have seen others introduce non-persistent cross-site scripting, or type 1 cross-site scripting, that's the same vulnerability as well. This video program uses the C# for introduction. The video will only introduce why the program can cause cross-site scripting. Will not provide a universal solution for all vulnerabilities, and do not recommend using it because it is not absolutely safe. Let's start by introducing the demo program. This is a Hello World program. Enter someone's name in the text box. After submitting, the hello space and the name just entered will be displayed in the output area. Let's first look at the elements in HTML. The first part is sample input value. There are two buttons in the field set. The first button will enter a regular value in the text box, and the value entered by the other button will cause XSS. The second is the primary part of the HTML, which has a text box and a submit button. And another submit button can prevent cross-site scripting. The last part has only one label, which is used to display hello and the name entered by the user. Then we will execute the program. Let everyone take a look at this demonstration program. What data will be input to cause cross-site scripting? I am now running this program directly from Visual Studio. I firstly press the normal button, enter the regular data, and then press the submit button. We can now see that the output label says Hello Yitian Technology Inc. Then I press the XSS hacking button. The program inputs a script string in the name field. I go on to press the submit button. Now we can see that cross-site scripting has been triggered. Many might wonder what the connection is when an alert dialog appears. This is because the appearance of an alert dialog signifies the ability to execute arbitrary JavaScript. In another video, we will demonstrate the extent of damage that cross-site scripting can cause. I don't modify the input and directly press another submit button on next step. The program will not cause cross-site scripting. This is a method to address cross-site scripting using HTML encoding, but it is not a recommended approach for handling cross-site scripting. Since the discovery of cross-site scripting in the 1990s, leading companies in various programming languages have continuously attempted to mitigate it. Despite the release of countless versions of the library, XSS still cannot be completely prevented. Therefore, it is advisable not to rely on HTML encoding as a primary means of safeguarding against this vulnerability, unless absolutely necessary. Finally, let's take a look at the server-side code. The main part of the program is on line 20, where the program receives the username from the front end, and without any processing, it simply sends the username back to the front end. I've set a breakpoint at line 20 to examine what data the front end is sending. Next, on the front end, I clicked the normal button to set the username as Yitian Technology, and then click the submit button. After entering debug mode, I move the cursor to username, and you can see that the front end has sent Yitian Technology to the server. Let the program continue to execute, return to the front end, and we can observe that the output label displays Hello Yitian Technology. Next, I will debug a case that will result in cross-site scripting. The program is also paused at line 20, and I've placed the cursor on username as before. You can see that the front end has sent the JavaScript string that was just entered. I press continue to exit debug mode, and back in the HTML. You can see that the JavaScript we entered in the username field has now triggered cross-site scripting. In the next video, I will introduce what hackers can do with this vulnerability.